percent of change, and if we have time, we'll talk about percent error. They're really basically the same thing. Again, all percent problems boil down to part over a whole equals the percent over 100. Every percent problem basically boils down to that. So the question is, in a percent change problem, we'll have something like this. Trey had $80. He spent $25. What's his percent change of money? Now, you wouldn't say 55, you wouldn't just subtract those. This amount, the amount he starts with, is the whole. Whatever you start with, that's your whole. And this, the amount he spent, the amount of change, that's the part. So what we would do is we say, well, he had $80, he spent 25 of it, and now we can find what percent of that is what he spent. So we could we could reduce this if we wanted, but we cross multiply, we get 2,500 equals 80x. And we go ahead and divide that. And what do we get? 31.3%. Sure. That's with a, well, yeah, that's with rounding up, right? So the key here to any percent change problem is the whole is whatever you start with and the part is the amount it changed. I don't know, he must have bought like someone a dinner or something, you know.
Himself a dinner. 2 dinners.
Kid buy 2 dinners.
Okay.
There might be difference about your request.
Someone's having a bad hair day. This is an 80s girl. Okay, going on. Next example. Meredith started the week with 400 sheets of paper. By the end, she had 356 sheets. What's her percent change? Now this is a tricky question because what we have here is I don't know the amount of change. It's very tempting to say that she changed by 356 sheets, but she didn't use 356 sheets of paper, did she? The part, this is you have to read, the part is the amount of change. So in this case, I need to figure that out. So she had 400, she used 356, or she didn't use 356, she ended up with 356, so we subtract those, and when we subtract those, we get 44. So she used 44 sheets of paper. So that's the amount of change, which means that's the part. The whole is how much? 400. So to figure this out, we're going to do 44 over 400 equals x over 100. We cross multiply, so 4400 equals 400x, and then we divide. And it's an 11% change. Any questions on that? I hope not. All right, so let's try these example problems in our notes. Without having a big word problem, I'll just say you start with 50 items, and then you lose 15 of them. You start, it doesn't matter what it is, dollars, pencils, crayons. See if you can set these up on your own.
Okay. Can I use my phone as my calculator?
For right now?
Same.
All right, in the first one, what's your whole?
15.
Your whole.
35.
50.
Wait, no,
Listen to my question.
Oh.
The whole is 50. What's the part?
35.
Let's think.
It's
The
15.
part, listen, the part is the amount of change, right?
Oh, here.
That's the amount of change. So if I lost 15, what's the amount of change? 15. I ended up with 35, that's true, but 15 is the amount of change. So we have to be careful when we think. So we have 50x equals 1,500, then we divide by 50, and what do we get?
30.
So it's 30%, a 30% change. Do you understand why it's 15? We don't always subtract these. You have to think about what you're doing. So in the next one, is 6 my part? Well, 64 is my whole, but the question is this my part? Is this the amount it changed?
No.
If I start with 64 things and I gain 6 more, how much did I change? 6. So is this my part?
Yes.
Yeah, that's my part. The amount of change is the part, so 6. Now I cross multiply and I get 600 equals 64x. And I get x is,
9.38.
yep, rounding, 9.38%. Now looking at these two, if I start with 45 and I end up with 10, is 10 the part?
No.
No, why not? Because it's not how much I changed. I changed by 35. About 78%, I rounded. Note in your homework and on your tests and quizzes, you will need to pay attention to, what you're told to round. All right, what's the whole in this one?
128.
Is 140 my part?
No.
No. How much did it change?
22.
12.
I mean,
12. Okay, then we cross multiply.
Wouldn't it be negative?
I'm about to talk about that. Thank you. But for now, we'll just use that 12. So we divide by 128.
$9.375.
I got 42.9%. Make sure you do top divide bottom. Any questions? That doesn't seem right. Did I do that wrong?
No.
Yeah,
I
you did.
did.
I think I did that wrong.
It's 9.375.
Yeah, I did that wrong. X should be 9.375%. There we go.
So what?
Okay, we'll come back to trying those. I want to.
Why wasn't this a negative?
Big brain.
Okay, that's what we're going to talk about right now. Okay, so if the amount went up, so that's just kind of like common sense. Like if it increased in value, that's a percent increase. And if the amount went down, what do you think that is? Percent decrease. Now, Ryan's asking, well, when I subtract or whatever, I got a negative. We don't need to use the negative. We'll just drop that and we'll just understand whether it's going up or down based upon whether the value went, like literally increased or whether it literally decreased. So we won't account for that negative other than just to understand whether we're going up or down. All right, so now, do something a little bit confusing, but it's not too bad. The greatest possible error. So whenever you're measuring something, now I don't know if you've done this at all, Trey, in biology or whatever, chemistry, okay, you guys haven't had chemistry yet, earth science, whatever it happens to be. But in science, when you do measurements, your last digit in your measurement is called the doubtful digit. And that's because you basically guess it. So if I have my ruler out and I'm measuring, and let's say I have, I don't know what end this is, but let's say this is 2 right here. And let's say this is 1.5 inches. And that means this is 1 inch. And then you might have a mark right here and a mark right here. So this would be 1.25 inch, right? And this is 1.75 inch. And then maybe you're measuring something. And whatever that something is, you see it comes to like right here. You're like, well, it's just past a half, right? And then so you guess this one. And you say, all right, well, I went past 1.5. That's a definite mark. It's between these two. So you might say, well, that's 1 and 5/8, you might guess, right? So that might be 1.55 inches. You might say that. Something like that, right? You're past a half and then you're a little bit more. Do you get what I'm saying? This digit right here is doubtful. Because I don't actually have a hash mark here, do I? So I don't know what it actually is. So if I say, all right, so I measured this thing, whatever this thing is, and it's 1.55. And maybe it's a box. Maybe I like have a square, and I'm measuring the size of a square. And this is 1.55, I said, and this is 1.55. But both of these digits are doubtful. Okay? So maybe I'm off. Like, it could be like 0.05 more, or it could be 0.05 less than what I actually read it. So what I want to find is the range of values that this actually could be. So each side, it could be between 1.5 and up to 1.6 because I subtract off that extra amount or I add up that extra amount depending upon what it is. So this is my range of values. So what I'm going to do if I'm finding this area is I say, well, the smallest the area could be area is length times width, right? Or base times height, either one of those. So the area could be that. What's 1.5 times 1.5? Okay, I'll just do it. 2.25 units squared, or inches squared. Or it could be up to this, 1.6 times 1.6. So that would be 2.56 inches squared. So this is my range of possible areas based upon the error in my measurement. Let's see here. Let's say, for example, Sarah measures her room to be 8 feet by 10 feet. Now, the last digit here, which would be a 0.0, is doubtful. I don't know if it actually is that, right? So, her room could be 7.5 feet, taking off that half, by 9.5 feet, or at the high end, it could be 8.5 feet by 10.5 feet. So all I'm doing is I'm taking that half and I'm subtracting it and adding it to see what my range is. So if I wanted to find the area of that, what's area? Area is base times height, so 7.5 times 9.5. So the first area, the smallest it could be, is 71.25. That's the smallest. And the highest it could be is 8.5 times 10.5.
89.25.
So what's the range of values? 71.25 to 89.25. So it's between those, right? Is the actual. All right. Greatest possible error. GPE. So let's say I measure something to be 4. I could be off plus or minus 0.5. Because that would be the next digit, right? Let's say I measure something as 16.8. The next digit would be the hundredths place, so I could be off by plus or minus 0.05. So yeah, go one extra digit. Basically, the greatest possible error is go one extra place. Plus or minus. I could be off, negative 0.05, or up 0.05. What if I had this? 185.83. Well, the next place is right here, right? So it could be off plus or minus 0.005. What if I had 22? I could be off by how much? Plus or minus what? 0.5. So it's not that bad, really. It's just taking it that extra place. All right, so let's say I have some areas. Maybe I have a 7 mile by 8 mile. And I have a 12 kilometer by 5 kilometer field or something like that. Maybe I have a 23 foot by 14 foot room. And I want to know, well, what is the range of possible areas? Based upon my last measurement is doubtful. So I increase or decrease this by half. So this could be at the high end, or low end rather, 6.5. Decrease it by that half. And this on the low end could be 7.5. On the high end, this could be 7.5. And at the high end, that could be 8.5, right? And if I wanted to find the areas, what do I do with these? Multiply them. So the lowest area is 6.5 times 7.5. What do I get?
48.75.
And the area of this would be 7.5 times 8.5. What do I get?
63.75.
Okay. What's the smallest this could be?
12.5.
11.5.
11.5, and on the high end, 12.5, right? And this one, the low end,
1.5.
and on the high end.
5.
So greatest possible error, you're just adding or subtracting that one extra decimal place.
51.7.
This is the low end, and at the high end,
68.7.
7.5, right? We want the extra. So this is the range, right? You see what I'm saying? All right, we'll stop right there. This one, we'll just say that would be 22.5, right? And times 13.5, we won't actually do it. And at the high end, 23.5 times 14.5.